Howdy tubes, welcome back to the Zach Life. Now sorry about the wind and the sun is right in my face. I can't hardly see you. So continuing on with my theme, I'm going to try to get this thing ready to drive where it's drivable as quickly as possible. I'm not worried about the inside anymore. Alright, so I've sort of got the first stage of the electrical done. We got everything in the battery box and most of it finished up. I'm going to walk you through what we're doing, what's going on and why. So this truck originally had what's called a series parallel switch, which is a set of relays and solenoids that take these batteries in sets of two and put them either in series or parallel. And you would put them in series to get 24 volts to operate the starter. The truck starts on 24 volts, and then put them back in parallel for the alternator to be able to charge this set. Now, disregard that. You don't need to know how it works. It's kind of complicated, but my point is it takes 24 volts to crank the engine. You've got your two negative battery cables that come to this, and this would be 12 volts here, and then these two positives are hooked to these two negatives, and then these are the two positive battery cables that go to the starter. This would be 24 volts here to here. Now, the only way these two batteries are charged is through this little onboard battery charger. The truck no longer can charge these two batteries because they're not hooked to the truck. They're only hooked to the starter. They're not in any way hooked up to the alternator. Now, this cable here, I've installed a couple of fuses back here. I don't know if you can see them. Yeah, I think you can. At least one of them. This here is a 24 volt cable that goes through a 300 amp fuse and up into the cab. Now, for whatever reason, this truck has already got put in here two battery disconnects that are under the floor. Anyway, this goes through the fuse to that battery disconnect, and then out of that battery disconnect, and runs all the way along the frame and up and through everywhere to the generator. And this is the actual cable that cranks the generator. The generator uses 24 volts. I wanted a fuse in case something shorted out. Also, it's fused. The generator pulls around 350 amps, 24 volts while cranking. And so that would be somewhat of a time delay. If something screwed up and the generator started cranking, it would eventually burn that fuse out after probably 30-45 seconds or something. And that's sort of a fail-safe. Also, if you remember, the generator is controlled by a PLC, and if you had some kind of failure and you're laying in bed at night and the generator starts cranking, or for whatever reason won't quit cranking, you can run up here and shut that disconnect off, open that disconnect, and kill the power to the generator starter. Now, this is the 12 volt bus here. We've got another fuse. This cable runs around here up through the floor, also to another disconnect up here. There's two, and then from there it goes up to the cab, and that's the main power for the truck. Now, these two cables do go to the starter, but that's the only thing they do. This other cable is going to power anything in this whole coach is 12 volts. There's actually nothing in the RV parts is 12 volts. Everything is mostly 120, except the inverter and battery bank will be 24, but there'll be a very isolated system. It's not like it's got 24 volt wires that run all through the coach. So anything that's 12 volts can be killed by that disconnect. So you pull up to the place you're camping, or you let it sit somewhere or whatever, you turn that off, and it turns off every headlight, every blinker, every power to every brake light on the trailer, and also keeps the battery from being able to run dead if you have a failure in your alternator or something, or if you have a short, it limits the ability to have a fire, whatever. To me, that's just a fail-safe for when you're not using it. And then also it's got a 100 amp fuse, which it didn't have from the factory. Most of these trucks that did not have series parallel switches, had a big self-resetting circuit breaker, like a 100 amp, I don't know how big it was, in the frame. This truck was not equipped with one, I guess because it had a series parallel switch. I'm not 100% sure why. But anyway, I wanted to show these are my two fuses, and these are the wires that can go everywhere. You can basically kill every bit of power that's in this coach from right there. So you just pull up to where you're camping, turn that one disconnect switch off, and you don't have to worry about your battery being dead or any other issues. So moving on, I've got this big cable here. I say big cable. I've got this cable here that's got number 10 wires in it. This is going to, let's see, it's going to have the trailer brake wire, a main power wire for the trailer, like to run the the breakaway system, whatever, to charge the battery on the trailer. And then it's going to have an additional wire that's the main light wire, and so the power that runs the lights on the trailer is going to be operated through this, and a fuse is going to be in this box, just a maxi fuse, and controlled with a set of relays that's in my junction box at the back. So the power that goes to the trailer won't actually be drawn through the wires of the truck, so if you have a problem with your trailer, it won't kill the lights on the truck. The other several wires are going to bring power back up here for this battery charger, and then I'll have an additional wire that runs back up, and I'm going to put a light bar above the cab on the truck, and that's going to power it. Okay, so we're right here, right inside the hood, and we're looking at the bus bars that connect the chassis harness, the engine harness, to the cab harness that goes inside. Now luckily I have got an original, or was able to obtain an original wiring schematic for this truck, and so I know what every one of these wires do and where they go. And what I plan on doing, I hate to cut this up because this truck is so unmolested, this is going to be hard to show, but there's that wiring harness splits there. There's one that heads back towards me and one that goes forward. I'm going to split this harness up through here. It just goes out of view, but comes out right here, and basically pull all of the wires out that come down right here. And what this is going to allow me to do is to keep the front chassis harness original. And then I have got this cable here that's got 16 wires in it. It's an 8-pair cable that goes back to my junction box, and I'm going to bring it up and pick up the blinkers, the stop lights, the fog lights, or excuse me, the load lights, and everything else off the bus bar that run the stop lights and the blinkers and the backup lights and the fuel gauge and all that kind of stuff. It'll have an additional smaller cable later that'll run these, come off of that bus bar, runs down the frame and picks up the temperature sending unit on the transmission and the two rear ends, but that'll be something to deal with later. It doesn't need that to go down the road. Anyway, I'll use what conductors I need out of that cable that goes into that bus bar for the lights and stuff, like I said, and then the rest of those wires will go up into the cab and go to other things like the generator start-stop switch, the air suspension control switches, all that kind of stuff. Alright, so quickly, I'm about out of light. I got the harness split. This is what went on down the truck. It's cut out. Alright, so I've got the original harness from where it started, where I cut it off, wrapped in this black stuff down on the ground. From where the original harness cover ended, kind of down in there. I know you won't be able to see it, it's too dark. But up to here, and then this is the SO cord that'll go to the back. We're fixing to go in and work on it. These are the wires that'll probably go on the inside, or maybe another one that connects here, depending on, I got to trace some wires out. But anyway, I've got the basic left and right turn, also used as stop lights, the tail lights, the marker lights, which would be the lights that go around the top. You can operate them separately from the tail lights, and the fuel gauge. So here's the junction box. This is the cable that comes from the truck, and then buried in here, some of these wires are the bigger cable that goes to the battery box. These wires up here, they're actually all 14.3 extension cords that are cut up. They go up and to all the lights, the tail lights and stuff. Right off camera here, can you see, right, that's the breaker box, that's the junction box. The junction box there has got this SO cord that goes everywhere, and everything conjugates right there. And so anything electrical in this coach goes through that box, and I'll explain what it is in a minute. There's two cables that go to the truck. There's a 10 gauge with 6 wires, and then there's a 14 gauge with 16 wires, I think. I may have those numbers wrong. But anyway, say for instance, the fuel level meter wire comes from the truck through that cable up in here into a bus bar, out of that bus bar down through a cable to the generator, into the generator junction box, to another bus bar, and out of that bus bar into a single black conductor, you know, automotive wire that snakes right over about this far to the fuel gauge. Now, I realize you can run a wire down the frame and have a single wire that goes all the way down there, but that's not the point, and I want to explain why that is. And so instead of having trying to build a wiring harness that runs down the frame or through the ceiling or something, you know, where you've got individual wires and you tape them together or you zip tie them together, whatever, and you break wires out. When you do that, you can have a lot of trouble both in the designing of it. You know, you say, well, I should have added another wire here. You know, I needed a wire that dropped down there. I needed another wire for a switch. I needed whatever. You have that problem, but you'll also run into a lot of difficulty if you don't have an extremely well laid out wiring diagram troubleshooting, or if you get a couple of wires crossed, you know, you get a wire crossed for your generator start switch and a light, you know, where do you start? It's nearly impossible to track that down. And so what this does is it brings everything together in a way that you cannot, you know, except by human error right in front of you, make a mistake. You know, you can make a mistake, but you can't get a couple of wires crossed in the ceiling somewhere, and when you bring it out in your switch or something, it's simply the wrong wire. You know, they all start with one color and end with one color. You know, you won't get a couple of wires twisted in a cable. And so what I've done, this is going to be hard to understand. It's probably going to be hard to show, but I've got all the different cables. You know, we've got the 14 gauge truck cable, 10 gauge truck cable, panel cable. You know, this is certainly not finished. There's a bunch of blanks. 12 gauge panel cable, water heater cable panel, I'm getting tongue tied. Water heater cable, generator cable, charge cable. Now you don't need to know what those are. They're just cables that go different places, and you know, I know what they all do, and that's all that matters. It also gives you a better troubleshooting ability than you can really get even with a wiring schematic, because unless you have all numbered wires, because you know which of those cables coming in the bottom of the control panel goes where. You know which cable is what, and then those cables are all color coded. So if it starts at the truck with a red white wire, you know it's red white back here. There's no changeover. There's no junction of wire anywhere. There's not a failure point anywhere. Is what I'm saying, between the places that you can actually physically see the wire ends. My main power cord comes into a junction box. It's right down underneath the sink. It's not under the sink yet because there's no sink, but it'll be under the sink. And it comes into a 50 amp main breaker, and out of that main breaker, through the floor, into the bottom of this junction box, through a double pole contactor, double throw contactor, and then into the bottom of the breaker box. But what that contactor will do, and this gets kind of complicated if you can wrap your head around, the contactor allows you to disconnect the short cord, the power cord, from the coach. At that point, now I don't have my battery box, my chargers, and my inverters yet. What that allows you to do is to have a couple of chargers connected to the short cord that'll charge my 24 volt battery bank. And that 24 volt battery bank will run an inverter, and the inverter will power the coach. Now this seems like a stupid waste of inefficiencies, but here's my idea behind it. So you pull up to someone's house, you probably don't need much air conditioning, maybe you're in Colorado, whatever, in the winter, and you simply plug the coach in with a 15 amp, with a dog bone adapter, with a regular 15 amp plug. Now what you can do is you can adjust your charger, because the ones I'm going to get are adjustable, to output, or rather to input, say 12 or 13 amps, something like that, whatever, to keep from burning this up and tripping a breaker. And you can take that, 13 amps times 120 volts is, whatever, 1500 watts, 1550, whatever it is, and put that into the battery bank. Your battery bank then can have power pulled out of it through an inverter and power your coach. I'm going to have a 6,000 watt inverter, so if you want to run an air conditioner, a hot water heater, and run electric, hot plate or something, you have the power to run all that, off your battery bank while it's being recharged by this. Now obviously you can't bring in 1500 watts and have a 6,000 watt outtake But if you're somewhere where you don't require much power, you know, as long as your average power consumption is less than your power input, your batteries won't go dead. I know that's probably really confusing to say. Now, I need to give a little bit of theory of operation. This coach is a 50 amp coach, meaning that you've got 50 amps, 240 volts to come in. You've got two legs that have nothing to do with each other, 120 volts. I realize, you know, this is a stupid way to put this, but in a way, you've got the ability to have 100 amps, 120 volts. Not really, but sort of, you know, 250 amps. And so this comes in the breaker box and is split up. And on one side, one leg has got the front air conditioner, the back air conditioner, the water heater, and this plug that's up there. You see it just on the edge of the camera, that will run the convection microwave. The other side has got the middle air conditioner, the lights, and the two plug circuits. So these air conditioners are going to pull, you know, about 16, 17, 15 amps a piece, depending on what the ambient temperature is. And they've got a thing in them called load shed. This is what this Dometic, you know, system has this as an option. And what happens is when the back air conditioner comes on, the back air conditioner has an output of 12 volts that comes up to the junction box. And from that junction box comes up to the front air conditioner. And when the front air conditioner sees that 12 volt signal, it turns the front air conditioner off. This is called load shed. And what this will do is only let the front or the rear air conditioner run at the same time, with the back having priority. So right here is a thing called a current sensing relay. And what this is this relay, when it sees a current above 22 amps, it closes. So that current sensing relay measures the combined current of the circuit that goes to the microwave and the circuit that goes to the water heater. Anytime that the combined current of both of those circuits is above 22 amps, it closes. Now, the load shed output of the back air conditioner, the 12 volt positive supplied wire, when the compressor is running, comes up to this junction box. It goes through that current sensing relay and to the front air conditioner. Now you can do the math. Air conditioners pull, you know, say 16 amps a piece. That's 32 amps plus 15 is just about 50, you know, more or less. Time you add the water pump and stuff, that'll be maxed out. And so what this does is, if the water heater is running and you turn the microwave on, that current sensing relay will close, and if the back air conditioner is on, it will turn off the front air conditioner. Now, what this does is this automatically, with a really simple little $10 deal, takes 4 items and only allows you to run 3. And that's basically all the current we've got. And so if the water heater's off, that's great. If the microwave's off, that's great. If one air conditioner's off, that's great. But if you turn the microwave, the water heater, and both air conditioners on, it kicks off the front air conditioner. Now, I did the front, not the rear, because if I'm asleep in the back, I want the air conditioner in the back to have priority. Now, when I'm going to run on inverter, I'm going to bring these 2 wires also over here and my control panel, and I'll be able to switch to a continuous load shed. And so even with the water heater and the microwave off, it'll only run 1 air conditioner at a time, and then I can manually select, you know, by turning the water heater off and on, or the microwave off and on, or whatever. So I've got both air conditioners running on high. It's worth a note to remember that, you know, I've got electric only heat, I don't have gas. And when the water heater is turned on, you know, when the switch to power it is turned on, that doesn't mean that it runs all the time. It only runs when it needs to warm the water up. And so this keeps you from having to worry about whether or not, you know, the heating element is heating when you want to turn the microwave off and on, or trying to look at an amp readout or something if you've got that. It just takes the guesswork out of it. You know, you just know that if you turn the microwave on and the air conditioner kicks off, the heater's on. There's just nothing to worry about. So anyway, I've got both of them running on high. This is going to be hard to hear. It turns the compressor off instantly, but the fan stays running for a little bit, and the fan actually doesn't go off unless the load shed, it tells the load shed to be shed for over like a minute or something, you know, if you just short cycle something. So I've got a 1500 watt heat gun. I think it's 1000 watt on the low setting, plugged in to the plug that'll power the microwave, and then the hot water heater is a 2000 watt, you know, plus this should be enough to trip the current sensing relay. You can see the green light on the relay. I'll flip it on, here we go. I don't know if you heard it click, but the air conditioner went off instantly. The hot water heater, see the air conditioner went off. You turn off the hot water heater and run only the heat gun, that still won't trip it. You got to have the heat gun and the water heater. So this is where a little pre-thought in your electrical system makes things much easier. So all I've got to do is I'm in here in the truck and I've got all these wires that come in from the junction box back there, and I've just got to crimp terminal ends on and put switches in. So this is all the light switches. These are all will stay factory. I've just pulled them out so I can get to these from behind here. This this switch I popped out and pulled the bezel off of and bought this off eBay. This is an old style on-end generator start-stop switch with an indicator light. It'll pop right back in this hole and look really factory, look really nice, I think, and be able to control the generator. These are the air suspension control switches. For some reason when I bought this truck, they drilled these 3 holes and had these 3 big ugly toggle switches with the little safety latch that goes over them, I don't know why, to run the heater. Obviously I fixed the heater switches, I don't need those. So I got all the switches back in it. I like the way the generator button looks like. When I get the dash closed, it'll look really nice. So I need a way to tell when the generator's running. And I bought this. This is made by Holley, like Holley fuel pumps. And this is a switch to turn electric fuel pump off and on in a hot rod. And basically it's a normally open, normally closed switch that opens or closes at 5 psi. And what I'm going to do is there's actually something back here similar to that. I'm not sure what that was. And the fuel filter. And I'm going to use fuel pressure to turn this off and on and to do a couple things. It's going to power this 24 to 12 volt, whatever you call it. This is not a transformer, but a voltage step down thing. And it's going to power in the coach the gauges, the temperature and oil pressure gauges, the hour meter, and also the little light that's on the switch in the dash of the truck. Got the little light on the generator switch to work. Take it from a 6 kilowatt generator to a 30 kilowatt generator. Alright, so I've about got this buttoned up. I had a little bit of change of plan here. I'm going to move the transfer switch into this box. There just simply wasn't room to put it over here. I got the these little deals there, the current sensing transformers. They go back over here to this little box and tell me how many amps and stuff we're pulling. This will bolt to the inside of the door, just like that. And then these 4 wires will go to a plug that's mounted in the door. That'll go to the 24 volt inverters. So I had to move the transfer switch over here. There just wasn't room in this box. But anyway, I've got it installed and all put in here. It's these wires here, the ones that will go to the inverter. Of course, the main power comes in from the bottom, comes out the top or out the side, makes a loop and goes up to the breaker box. This is the plug that'll go to the 24 volt converters. This is a 120 to 12 volt power supply. I had a temporary wall wart rigged up, but this is what will run the let me think. I guess the only thing this actually does is run the low voltage. I'm laying my back here on my side. The low voltage to the Dometic thermostat system. I guess that's about it. PLC. Got the bus bar here, the one I call the wall bus bar. These are all the valves that go to the air suspension. This is just a plug that's powered from the plug circuit to run the power supply. I guess that's about it. I know this video's been kind of boring, but it's just another step, and I'm trying to show them all. I know it's been a while since I had a video up. It's I've been extremely busy. It's been muddy, been raining, and that makes everything I do for a living harder. But I've got several more coming. I've sort of got started on several other videos. Hopefully in the next within the next month, I'll actually be able to drive this thing to move it, and I've got several starts on several other systems, air system, and need to go with the drive shaft made and everything else. But anyway, I appreciate you watching. We will catch you on the next one.